Hi, question number 9. With respect to the origin O, the points A, B, and C have position vectors given by OA is equal to 2, 1, minus 3, OB 0, 4, 1, and OC minus 3, minus 2, minus 3, minus 2, 2. The point D is such that ABCD is a trapezium with DC, vector DC is equal to 3 vector AB. Find the position vector of D. Part B, the diagonals of the trapezium intersect at the point P. Find the position vector of P. Part C, use a scalar product. Calculate angle ABC. Okay, for question number 9, we need to find the position vector of D given those vectors. And the conditions is DC is equal to 3 times AB. So what I'm going to do is I'm going to try to find the vector AB, which is AO plus OB. And if we were to do AO plus OB, we'll get minus 2, 3, 4. And of course, this is going to lead to DC, and DC is 3 times AB, so 3 times what we just found over here, 3 times that vector which is here is equal to minus 6, 9, 12. Now this is DC. And also, to find DC, I need DO plus OC. So if we were to do DO plus OC, we'll get the following equation. And of course, rearranging this, we're going to get DO is equal to minus 3, 11, 10. Therefore, position vector of D is going to be the negative of that, which is then 3, minus 11, and then minus 10. So here we are. That's the position vector of D. Now, in part B, we are told that the diagonals, they intersect at this point. Now, this is a trapezium. So, of course, I can find the vector equation of AC and the vector equation of DB. Now, first of all, I need to find the vector AC. So, what is vector AC? AC is AO plus OC, which leads to the following vectors. So after doing this, this is what we get for vector AC. Therefore, a vector equation of the line AC is going to be equal to, let's say here, OA plus TAC. All right, so what's the vector equation of the line AC? I'm going to say it is simply OA, which is 2, 1, minus 3, plus some parameter t into AC, and we just found AC to be minus 5, minus 3, and then 5. Now, just like I found the vector equation of line AC over here, I'm going to find the vector equation of line BD, which entails to find BD. So BD is equal to BO plus OD, leading to the following vectors, that is the following vector. And of course, now I want to find the vector equation of BD. Let me just call it RBD, which is vector OB plus some parameter S times the vector BD. So, and if we were to do this, we'll get the following vector equation of the line BD. So what we're going to do now, we're going to equate this to this and build equations to be able to solve for those parameters. And if we do so, we get the following equation, and these are the simultaneous equation. This is 1 and this is 2, and then adding these two up, you should be able to cancel those two, and 9 plus 75 is actually 84. So we have then 84S is equal to 21, leading to S is equal to 21 over 84, which is then 1/4. And therefore, I can substitute the 1/4 into any of the above equations. So in our particular case, maybe I can take this one here. But if you were to find t, you can substitute t into this one. Basically, this is S, so I'm going to take that one, which is then, you can take any of those because if you were to find t, so t is going to be equal to 1/4 as well. So s is equal to t is equal to 1/4. So substituting any of those values in any of those equations, you should be able to get the point of intersection, which is this one here. So that's then 3/4, 1/4 minus 7/4. Here we are for part B of the question. Now we need to use a scalar product to find the angle ABC. First of all, I'm going to find the modulus of AB, and because the vector AB was found to be -2 and then 3 and 4, so we can use the formula here and we get this 4, 9, 16, right? Comes to square root of 29. Similarly, I'm going to find the modulus of vector BC. And now because I want to find the vector BC, and BC turns out to be BO plus OC, that is then -3, -6, and then 1. So we can put this over here, leading to square root of 46. Now, of course, we know that cos of the angle ABC is equal to AB dot product with BC divided by the magnitude of those two, product of the magnitude of those two vectors. All right, so here we are. So let us find the dot product of AB times BC, which leads to this. So now if we were to do this dot product, it's going to lead to 6, all right, minus 18, then plus 4. So then what we can do, and we can divide this by the magnitude of AB times the magnitude of BC and take the cos of this. All right, so that's cos of ABC. And so we're going to divide this by the square root of 29 times square root of 46. And all of that comes to negative 0.219 and so on. So I can say that ABC, if I want the acute angle of ABC, it's going to be 180 minus the cos inverse of minus 0.219. And of course, this is in brackets, and that's going to be then be 180 minus, just do this in a calculator, 102.650. Okay, so cos inverse here. Right, so I have my angle ABC as to 3 significant figures. It's going to be equal to, just spell it, 77.3 to 3 significant figures. So here we are. That's question number 9 on vectors. Take care.